welcome back everybody, and thanks for stopping by and checking out the next video in our MPLS Layer 3 VPN section. In this video, we're going to be taking a look at our first BGP, or our first PE2C routing video revolving around BGP. Figured I would get that right one day. So what we're going to be doing in this video is actually pretty straightforward, and we're going to be crawl, walk, run in our approach here. So we're going to be configuring a BGP peering between CSR6 and R15. That's going to be our first step. And then we're going to configure a peering between XRV9 and R14. Now the goal here is to show you both iOS and XR as PE2C routing protocol or routers. Pardon me for that. So we're going to configure CSR6. We're going to configure the peering here. We'll go through and set the IP addressing up for all this stuff. We'll do the same thing on XRV9 and R14 here in AS10 and get that all squared away. We'll get the configuration up and running and operational, and then we'll go ahead and advertise some routes and go from there. So without any further ado, let's begin. So I'm going to go ahead and I'm going to start on CSR6, and we're going to go ahead and on interface gig 3, the very first thing that I have to do is, do show run VRF. We had the VRF configured, right? Now we have to go to interface gig 3 and type in VRF forwarding is going to be C1. I'm going to type in the IP address here is going to be 101.6.15.6/24. And it says Gig 3 is linked to a VRF. Please enable IPv4. Yep, that's a good point. I forgot about that. C1, address family, IPv4, and there we go. So interface gig 3, IP address. There we go. So do show IP interface brief. There we are. So we're going to go ahead and actually no shut that. Give that a second or two to come online, and then we'll be in good shape. I'm going to go over to R15, which is not on that. I don't have that one pulled up yet. Haha. Okay, so I'm going to go grab R13, pull it up. I'm going to pull up R14 and pull it up, and then R15 and pull it up. Perfect. So now I'll be able to type in host name is going to be R15. We'll type in interface gig 0/0 is IP address of 101.6.15.15/24. We'll no shut the connection. No shut, not no shoot. And then interface loopback 0. IP address is going to be, I'll go with 10.1.1.15/24. Now, in order for this to work, I'm going to go to router BGP 15. No BGP default IPv4, and I'm going to type in neighbor of 101.6.15.6, remote AS of 100. I'm going to go ahead and I'm going to advertise the prefix. First, activate the adjacency. I'm going to type in network of 10.1.1.0 Okay, so that's the configuration that I need. Now I'm going to go over to CSR6. I'm going to type in router BGP 100, address family IPv4 VRF C1, and I type in neighbor of 101.6.15.15 remote AS of 15. So here in just a moment or so, we should get a peering, an update from the R15 device that the peering is up. There it goes. And if I jump out of global config, I'm going to do some verification commands first because we're only a couple minutes in. If we do a show IP route VRF C1, we'll see that we have a BGP learned route right there. Now if I do a show BGP VPN-v4 unicast all summary, we'll see that we've learned a route right here, right? We've learned a route. Now if we do a show BGP VPN-v4 unicast, and I look at the all, and I look at the the do come in here, notice we have 10.1.1.0/24. If I grab this route right here and expand it, what you'll see is some of the BGP configuration. So basically what we see here is we have one path available. We can see that this right here is this right here specifically, what I'm highlighting is the AS path. There's only one hop in the AS path list right now because of the fact that we are only peering with one device and we've only learned one route. Now our next hop is going to be 101.6.615.15 out VRFC1, which is going to be directly connected to us. It was advertised with the network command, and everything else looks pretty squared away. The extended community value of route target, we are basically saying, you know what, we're going to allow this to be propagated into BGP with the route target value of 1.1.1.6:1, which is what we configured earlier. Now the MPLS labels output is a little tricky to read sometimes. So MPLS labels right here. If we look, we have in is this one ties to this output right here. So in is 42. Out label, there is no label because right now we don't need anything else to populate. Now what this means is with 42 is CSR6 has allocated label 42 for the prefix of 10.1.1.0/24 that was learned from R15. Okay, that's basically how this comes into play. Now let me do some tweaking here real quick, because by having it set up the way that I do, it doesn't make a ton of sense. So let me make a quick change here. So I'm actually going to go to interface loopback 0. I'm going to type in IP address is going to be 10.1.15.0. And actually, let me go 15.15. 15.15. Yeah, that'll actually work. 10.1.15.0.15. And the reason why I'm changing the IP address from 10.1.1 to 10.1.15 is because if I was to go to R13 or R14 and try to advertise 10.1.1.14, it would give the illusion that 14 and 15 are directly connected to each other or are on the same LAN segment, which they are not. I'm trying to say, okay, this is customer 1 right here, and this is router 15, and we're going from there. So that's basically how I'm going to associate this. By doing this and changing that information, what's going to end up happening is that route is going to disappear. It's no longer in the peer. If we were to just come in here and do all, guess what? We're no longer learning that route. So I have to go back to CSR or router 15, type in, let me go ahead back to the BGP config and make a modification. Actually, I hadn't thought about that beforehand. That's why I'm making the modification now. Let me go ahead and remove this network command, pull this out, and then I will put in 15.0 like that. We go back to CSR6. Now we've learned the route. If we come up here to 15.0, there we are. So now it's using a different label value. That makes more sense. Now, by doing that, what I'm going to go do is I'm going to check out CSR4, show BGP, VPN v4, unicast all, and I've learned 15 from, or I've learned that prefix from CSR6. And if I expand this, if you look at CSR6 in the output, we see that its in label is 43. If we look at CSR4, we can see the in label now is no label, but the out label is 43. So what gives? Why does that make a difference? Well, now what's happening is when this route gets advertised, CSR1 is going to learn it, right? Let's go take a look at CSR1. Show BGP VPN v4 unicast all summary. I actually haven't learned any routes from that guy. So let's take a look at as to why. So show run VRF. Well, that would be why. VRF definition C1 address family IPv4 and v6. Let's try it now. Give that a couple seconds for it to, there it goes. So I neglected to add the correct configuration. I'll edit that in the video. I'll make sure you add the address family IPv4 or else the routes won't be learned. So now if I come in here and I grab this 10.1.15 prefix, I'm going to be learning it from two different route reflectors. I'm going to be learning it from 10 and from 4. Now you'll both be getting the label value of 43. Now this out label is what we need to pay attention to. So why does it say out label on this side but in label here? What is the significance of this? Well, let's do a packet walk from the PE perspective first. So we go from the ingress. So traffic from AS10 is going to AS15. So we're going from this side of the topology to this side of the topology. So what's going to end up happening is CSR1 has traffic come inbound from AS10 going towards 10.1.15.0/24. What's going to end up happening is this label right here is going to be used as the VPN label, right? This will be the bottom label. Now, if we do a show Ceph 1.1.1.6/32, I'm sorry, show IP Ceph 1.1.1.6. I'm going to use two different labels to get there. I'm going to start up at 23 and 27, and it'll load balance across the wire in order to get there. Now, what's going to end up happening is these labels here are going to be used to get us from CSR1 to CSR6. Whatever path that takes through the backbone is LDP dependent and things like that. But this label right here, 43, is going to be used to get us to CSR6 and then out to the customer. Okay. Now, if I look at the show MPLS forwarding table and I look in here, I don't see a 43, right? There is no 43 at all. So where does the 43 come into play? The 43 comes into play when the route from router 15 is advertised to CSR6. CSR6 propagates that, or allocates the label first to the prefix, then propagates that information to the route reflectors, CSR4 and XR10. They in turn advertise that to the egress or the remote provider edges. They get that. And when we do a show MPLS or show BGP, VPN, v4, unicast, all, when we look at this prefix right here, we're going to say, okay, when traffic is going to 10.1.15.0/24, make sure you use the VPN v4 label, the VPN label, as label 43. That'll be the bottom label. So that'll get us to, so when the traffic is received by CSR6, CSR6 looks in its show MPLS forwarding table, and we go all the way down to label 43. Label 43 says, okay, there is no label here, but notice that we have this unique looking route here. This means that it's a customer learned route, that gig 3 is in a VRF, and the next hop is R15. When we send traffic from, let me just double check to see what CSR5 would see. CSR5, show MPLS forwarding table. When we see label 43, 43 isn't even going to show up here, right? When we get traffic from CSR1, CSR1 propagates traffic and it either hits CSR4 or XRB10, one of the two. Traffic comes in on here and we have the next hop of router 6. Router 6, in this particular case, has a POP label. So when we send the traffic towards CSR6, what's going to end up happening is the LDP label is going to get removed, and then we're going to forward the traffic down towards CSR6 with label 43. Now let's finish the configuration on the other side. Let's go to XR9 and configure him real quick. Go ahead and log in. Go to global. We'll type in, we'll go to router BGP, or actually, I'm sorry, interface gig gig 2 VRF C1 IP address is going to be 101.9.14.9/24, and we're going to go ahead and no shut that interface. We're going to commit that config. That'll bring that configuration up online. Do show IP interface brief. Beautiful, it's up online now. Now we're going to go to router BGP 100, and then we have to specify the VRF. So VRF C1. And then in order to make all of this work, the very first thing that we have to do is type in the RD value. The route distinguisher goes under here, 100:1. I'm also going to enable the IPv4 unicast address family. I'm going to exit out of here. I'm going to type in the neighbor of 101.9.14.14, remote AS of 10, address family, IPv4 unicast. Now, in order for this to work, I need to have a route policy associated for this peering to come online. So I'm going to type in route-policy. I'm going to type in pass in and pass out. I'm going to type in root and type in route-policy is pass. I'm going to type in pass and exit out, show config, and this is the syntax. So I have my route policy. The route policy is needed to allow any eBGP peerings to pass actual traffic back and forth. It's like a filter in place. If the route policy is not associated to the peering, then the peering will come up, but no routes will actually be exchanged until you associate a route policy. So I'm going to go ahead and I'm going to commit that config. And then I'm going to go over to R14. I'll type in host name is going to be R14. I'll type in interface loopback 0 is going to be IP address of 10.1.14.14/24. And then I'll type in interface gig 0/0 IP address of 101.9.14.14/24. And I'll no shut it. Now, once this comes online, I'll be able to go to router BGP 10, no BGP default IPv4, neighbor of 101.9.14.9, remote AS of 100. I'll activate the adjacency, and I'll type in network of 10.1.14.0, mask of /24. So now, after a short period of time, this BGP peering should come online, and it does. So now if I look at the show BGP IPv4 unicast, I should see that the 10.1.15 network is now there. Now let's go to XRV9. The peering is now up. Let's do a show BGP VPN v4 unicast VRF C1, and I'm going to look at the routes that have been learned. I see 14s here, so I'm going to hit the up arrow and I'm going to grab this prefix right here. And now label value here, notice that it doesn't jump out at you, right? Nothing jumps out. So it's a little disconcerting that it's like, well, where is it at? Well, it's actually right here. Just in a slightly different spot. So label value 24,026 is there. Now if I go over to CSR6 and I look in the forwarding table, notice that you don't see that prefix at all, right? It's like, well, where'd it go? If I do the show BGP VPN v4 unicast all, I can see 14 is here, right? If I do this again and look at 14, I see it. I see 24,026 is here. So I should have reachability end-to-end now. Now if I go to R14 and I do a trace route to 10.1.15.15 sourcing from loopback 0 numerically, you bet your bottom dollar I can get there. I hit CSR9, and then I'm immediately label forwarded. I have label 43, label 43, label 43, label 43. When I get to, I take the path 4 to 5. So I go to CSR5. CSR5 gets it, pops the label. He's going down, and we knew that would happen because we're here on CSR5. When we go out towards CSR6, and it's a little misleading. It's like, well, why am I seeing the public IP side showing up? Well, the only reason you're seeing that is because that is going to be the outgoing interface that you're going to be using to route towards the customer. That's why you see that. So this right here is the peering that you would expect to see. So that's how that comes into play. So we see label 43 show up here. That's expected. So we have 2 label stack, 2 label stack, 2 label stack until we hit router 5. When we go from router 5 to router 6, we pop the LDP label, and then we go down to just the VPN label. Okay, we get that, and that's how we forward the traffic. So when we go to send traffic on from CSR5, when we get label 16 right here on CSR5, we do a label 16. We're going to pop the label going down towards router 6's or CSR6's loopback, and then we just forward the traffic based off of that information. So we don't need to know that there's a VPN label. We just pop the LDP label, we forward the traffic down via the VPN label via native IP. And then CSR6 gets that right here. We do a show MPLS forwarding table for label 43, and it tells us that it's going out towards the VRF, towards the customer. And that's basically how that comes into play. So that's how that would work. So that is an MPLS Layer 3 VPN end-to-end trace route. Now, can we do the other way around? Sure. Let's go do that real quick. Show IP route. Let's do a trace route to 10.1.14.14, sourcing from loopback 0 numerically. And we get there all day long. Notice how we use label 24,026 in order to get to XRV9. We get there all day long. Everybody's happy. And that's what you would expect to see. You don't want to see anything else other than this, because if you do, that's a bad sign. That's an indication that there's a problem in the network somewhere that you need to go figure out. So we have label switch paths across the board, and when we get to router 3, we look at label 33, show MPLS forwarding table label 33, we see a pop label, and when we get to XRV9, we do a show MPLS forwarding table, forwarding labels 24.0.026, labels forwarding, let's see, 24.26. I might have to do labels. Oh, that's right, I forgot. 24.026, and for some reason, detail. Yeah, for whatever reason, it gives me some weirdness here. We'll just type in 24.026. Yeah, it's easier to type in the prefix of 10.1.14.0/24. Why is that not showing up? All the way down there. Yeah, it's a bit weird why it doesn't go give me the output. It's definitely does point outwards towards it. It's easier to look at the show BGP VPNB4 unicast VRF C1 and look at the prefix itself and know what it does. But we can look at the forwarding table and see that it's unlabeled. But for whatever reason, actually, let me try it this way. Forwarding labels 24026. Let's see. I'm not really sure. Hardware egress. Yeah, for whatever reason, it doesn't like showing the output. I thought there might have been a prefix available to it. Prefix of IPv4 unicast, and then 10.1.14.0/24 detail. Yeah, it doesn't. I'm really not sure why it's not showing this information, but we can tell by looking at the show MPLS forwarding table that it's working the way that it's expected to. I actually prefer this command. It tells you where it's going to go, gives you a next hop. So whether you look at this output right here, or this one right here, or you look at this output right here, it tells you where it's got to go. This one's a bit more specific because it says it's going to go out gig 2 towards the next hop of 101.9.14.14. But you can tell that by looking. You just can't drill down to it like you can in iOS. So that's basically how all of this comes together. That's basically what you need to understand about this whole process. So with that being said, ladies and gentlemen, thanks for stopping by and hanging out with me in this video. And until next time, guys, take it easy.